from sklearn.datasets import load digits. Okay. Now there's some other things I'll be using later. So let me also import from sklearn.decomposition import PCA from sklearn.metrics import classification report. Okay, let's see. I must have made a spelling error somewhere. It shouldn't be taking this long. Okay, all right, so it works. All right, so let's load up the digits. Digits equals to load digits as frame equals to true. As frame equals to true makes the data to be loaded as a data frame. And df equals to digits.frame. Okay. Now, let's say length of the data frame as length. And then what I want to do is I want to make a new column that calculates the distance. So I'm going to say df of distance equals to, I might get a, using which one I should be using. Okay, so df distance equals to np0's length. This last line, what it does is it creates a new column of just zeros, so that if you look at df head, I explained that it has all these pixels, right? So pixel 0, 0 through 7, 7, and its target 0 through 4, and then the distance is right now 0. We're going to populate the distance later with some function so that we can use it for k nearest neighborhood. KNN methods.
Professor, can you go back up real quick?
Yeah. So df distance and p0's length.
Is that how it usually goes?
Okay.
I'm supposed to be like,
Now we're going to shuffle this up. df2 equals to df.sample. Frac equals to 1. Dot reset index. Drop equals to true. Training set size, it will be length times 0.8. And then now what I'm going to do is I'm going to split the training data frame and the test data frame. So from the shuffled, df2 is the shuffled one, right? So from there, I'm going to take the first training set size. And by the way, if you know that there is no other variable that starts with training set, just complete with tab. So you can tab complete. I think this one. Tab complete. Oh. Yeah. Okay, so now, all right, so tab completes, right? Okay, so we have the training set as anything from beginning to the training set size, and test set would be df2 training underscore and then tab. Yeah. And then colon. So shift enter. This cannot be a float, so I have to make it as an integer. Okay. You can't have the indices as a non-integer, so you should put that there. Oh, you might be working with a new, a different version of pandas, but the standard is that you need to put int. Okay. All right. So if you look at the data set, you see that some values are 0, some values are big. So if you randomly picked, say, pixel 5,4 and picked max, you see that the highest value it gives you is 16. The minimum would be 0. So you can see that the data set has values between 0 through 16. Okay. Now, we will have to define a distance function. So let's define distance of two vectors A and B. And here I'm going to assume that we have some kind of a NumPy array and we're calculating the distance between them. And what I'm going to return is, well, it's a sum of, NP sum of, difference between A and B squared, right? So if you do A minus B, every coordinates will be subtracted, and you square those so that it's positive, and then you add them up. Of course, to be the true distance, you need to take the square root, but square roots are costly. And another problem is, another reason is, k-nearest neighborhoods only use the distances to find the closest points. So if the square root is closest, then so is the non-squared root version would be. So for our purpose, although there should be np dot square root outside to give you the true distance, this would suffice, right? So this is the usual Euclidean distance. All right. So let's try to see how this thing might work, okay? Suppose I take the test, the first one, I log 0. Okay, so this is the first one. And target is 0. This value is 0. I don't like 0. Let's try, what's on the next one? Really? Target is 1? Okay. Okay, target is 6, okay. Test.ilog2 is target is 6. I was a bit worried because I shuffled it. The original ones go by 0, 1, 2, 3, 4, but then after shuffling, the order shouldn't be regularly ordered. So, yeah. Yes?
I'm getting an index error when I do test.ilog2.
You might be working with really old version of Pandas. Are you working on Colab?
Yeah.
This is now the standard one. Did you have the dot?
Yes, I have the dot.
That's strange. Anyone else using Colab?
I'm using Colab and it's fine.
It's okay?
I got the same thing.
Then maybe you forgot the colon here. Test df2 training size colon at the end.
No, I have that.
Oh, maybe it's because you don't have the int.
I put in the end.
You did.
Yeah.
I have no idea. Try doing test.head see if it does give you something like this. It should start with 1437.
I got something. I got a 0 by 66 matrix.
No, that's not right. I don't. Oh, I think you may have not put as a data frame. As frame.
Yeah, I got it.
Yeah, okay. I'll have to look. I don't know what's the problem. Okay. All right.
I have a question.
Yeah.
Should the target number should be the same as you, or
The target number should be what?
you have 6 and mine is 7?
Oh, it's randomly shuffled.
Okay.
So it's different. Yeah. So my goal is to figure out how to have the KNN algorithm determine that this is really 6. Okay. So first of all, you can do imshow plt dot. Let's try to imshow this. Where is it? Test.ilog2. I copied it. No, not that one. Let me copy this one. Put it in the imshow. But the thing is, I need to reshape this, or else it doesn't like it. So reshape. Oh, I think it has to be numpy array to do that. Numpy array. Make this test.ilog. And remember, the last one is the target, right? So I just need the first. Oh. Right, okay. I just need the first 64 of them. So the way you do that is by putting, I think it's like 64. Okay. Yeah. Okay. Okay, so I make it to numpy array, and I reshape it as 8 by 8. Let's see if it works. All right, good. It worked. It does look like a 6, right? And you could also make the color map, CMap, color map as gray underscore reversed, so that the low values are white. So zeros are white and high numbers are black. Okay. So this is 6, apparently. By the way, this was downsampled from the 28 by 28 MNIST set, or maybe the ones that were more higher resolution. So it looks weird, but it really started from somebody's handwriting. So somebody wrote this in hand, and it was downsampled to give you this. Yeah. Yes.
Downsample it to save processing power?
Yeah. Because for KNN, it's just 8 by 8 is just too much. 28 by 28 is too much. And we're going to make it even smaller by using PCA today. Okay. Did you get the picture shown?
Yeah.
All right. So we humans can see that this is 6 easily, right? Yeah. But trying to teach the computer that this is 6 is a bit hard. So this is the way we're going to do. First,
Professor,
yes.
I got a like 7 or something.
That's it because some of you will get different numbers. I mean, most of you will get different numbers because we randomized the thing. Okay, everyone will have different numbers. Okay. So what I'm going to do is I'm going to populate the distance in the training set by calculating the distance between this one and each item in the training set. Oh, by the way, one nice thing about KNN is you don't have to train anything. The data set, training set itself is the training set because you just have that stored in the memory and then you just calculate distances when you need it. Okay. So I guess KNN would be useful if you don't have to predict that much. Okay, if you need to use it a lot, then it's a bit wasteful. But if you don't need to use it that much, then KNN could be good enough. Okay, so here's what I'm going to do for I in range training underscore and then tab to tab complete training set size and training.loc. So let me explain a little bit about LOC. We've been using iloc a lot, right? Iloc, this I means integer location. So when you have iloc, you use pair of numbers or just numbers to locate various parts of the spreadsheet. But if you do just loc, then you have to use the row names and column names. Now, row names are what's called the indices. You can see here. These are indices. So this is test. What is iloc 0 would be LOC of 1437. Okay, 1437 is this row's name. So if you do test iloc, we did 2, it actually calls test loc 1439. That's how it works. Is that okay? Test iloc 0 will be same as test loc 1437, test, and so on and so on. Okay. And also, you can, for loc, you can also feed in the column names as well. Okay. So what I'm trying to do is use loc. Now the thing is, training, we started from 0. So in the training, whether the 0 is same as the index 0, so I'm just going to use I. But then in the column name, we want the distance. And I want to populate the distance by using the distance function that we just did. Distance training dot iloc I comma first 64. So if you do colon 64, it fetches the first 64, which is the bitmap data, right? It's actually the picture. And then between this one and the one that we just chose, we did test.iloc2. I want this to be 6, right? So 0, 64. So what I'm doing is, here's the, well, I didn't show the training set, but test and training will look similar. And what I do is for each of the points in the test set, I take that vector and calculate the distance between that vector with the iloc2 in the test set, this thing that we saw, this one, and populate the distance column with this for loop. Okay, so this, if I execute this, it's going to populate everything with the for loop. Okay, and then I'm going to do training.sort values by distance. And then let me see the first 5, head 5. So if you want to have higher k values, if you want k7, you can look at first 7. Let's just look for first 5. Shift enter. Okay, these are the closest, the ones that are closest to what we are trying to look at. Let's see what they are. Oh, you see that? You see that? What just happened? We just saw that this mysterious unknown thing, which the computer wasn't able to see, has the 5 closest neighbors as 6s. So what would the computer think? It must be 6. That's the conclusion, right? Does that make sense? All right. So that's what we are going to do for every one of these things. So let me first write down the classifying function. inspired by what we did so far. Okay, so classify item, and we're going to use the training data frame, training size, training set size, and then for I in range, training set size, training.loc, well, we've done it, so let me just copy that one. I'm just going to copy this one here, paste it here. Okay, except that instead of the test, this will be just item, and because we've already sliced the row, you just need to get the first 64 items from there. Okay. Now once you're done, we can figure out the nearby points. Nearby points are training dot, oh, this one we also did. We're going to do this, copy this one here, paste it here. So this gives you 5, k equals to 5. You know, this just means I'm commenting. You don't have to put this down. This one is just commenting. This 5 means k equals to 5. So I've selected the lowest 5, the closest 5 numbers. Okay. All right, and then mode would be, oh, this I haven't done, but I should have shown you how to do this. What I'm going to do is take the nearby points and get the list of targets. So what this does is it fetches this column, target. Now in our one example that we did, it's all 6, right? But there could be some mixes of different numbers. So what we're going to do is we're going to get the mode. Okay. So you fetch the mode from there, and then we're going to return. First, make the mode into a list so that it's easy to manipulate, and then we're just going to return the first item there. So doing so is going to give us the classify. So let's try to classify. I don't know what happened here. Okay, classify. Let's do test.iloc2. Should give us 6. Okay, good. We can also do classify test.iloc3. What's in there? 2. Okay. Are you done typing this? Are you still typing? Okay, now let's see what's in the test again. So what's in the test? Is it 0, 1, 6, 2, 2? Yes, it was right. It's 2 and it's right. So it's doing a good job. So now what we have to do is we have to classify everything. So let's do the following. So target true target, I'm going to make an empty list, and then target predict will be another empty list, and we're just going to go through everything in the test and just classify it. So for index, comma, row in test dot iter rows. You can also tab complete here because iter are, then you can tab. And then we're going to do target underscore true, tab complete, dot append, dot append the actual value. So the row target value will be stored here. And target predict will be appended by what the classifier append does to it. So we classify the row, we do that, and then once we are done, we're going to print the classification report with the target true and target prediction. Okay. Now let's do Shift Enter. And what's going to happen is that this is going to go forever. I think mine went like 1 hour. It depends on your computer. Maybe Google Colab's a little faster. I wonder if Google Colab's faster. But the thing is, this is astoundingly good. Like, it has like 99% accuracy, or even more, 99.8. So I was quite surprised how good this is. But it's really slow compared to the other methods. This is just, yeah, unbearably slow. Okay, so it's still going to run. There's no way to, no way we can finish it. So let's stop. We're going to interrupt the kernel. Now let me show you how the PCA thing works. Okay, so we've imported the PCA, and let's use PCA with 4 components. Number of components equals to 4, and then PCA.fit training.iloc. I have to do this strange thing because when I do the PCA, I should only be fitting the bitmap images, the vectors, so the 64 length vectors. Okay, so I put the first column here because I want all the rows to be fitting the PCA, and then column 64 just fetches the bitmap information. Okay. All right, so I'm going to and components. Sorry. Shift Enter. Okay, so I get the PCA done, and what it did was it found the components for me. So PCA components underscore dot shape. You see that it's 4 unit vectors of length 64. We know that it's going to be a unit vector. Let's see it is a unit vector. PCA.components underscore 0. And, well, it's this one. But I can also take np.sum of the square of these numbers. Then it's almost 1, right? So it's a unit vector, okay? So this unit vector is going to be used as the first, this is the first component, and so on and so on. Now, what I need to do is now I have to compute the components and add it to the training set. So see, there's our training set right now is 66 columns because I have this distance thing. But I need to add component 0, 1, 2, 3. So let me put a for loop. For I in range 4, training, I'm going to make a new one, comp plus string of I equals to np.zeros, training set size. Okay. There must be an easier way than this one, but I couldn't find any. So I'm just making, by doing this, I goes from 0, 1 to 3 and stops, right? And then it makes a new column, comp 0, comp 1, comp 2, comp 3, with all the zeros. Oh. It's strange, like different versions of pandas throws different errors. Well, let's see if it's done well. So training dot head. Yep, I see comp 0, 1, 2, and 3. Okay? All right. So these are indeed made. Now I'm going to populate those. So what I'm going to do now is to compute the component, 0th component, first component, 2, 3, first 4 principal components, and we are going to compute them and populate here. Okay, so we're going to do a for loop for index comma row in training dot iter rows x equals to np array dot array of the training dot loc index comma pixel 77. Now for some reason I need to use the LOC because the index is this one, and if I'm doing that then I can't use 64, so I'm doing this one, which is the last value, right? And I'm going to reshape this into a column vector. You know how to do column vectors, right? And then now I just have to get the components, I just have to do the matrix multiplication. So I'm going to do PCA components underscore at x. So this matrix multiplication is done, but I need to reshape into a flat array in order to put this into the next to the training set. Okay. So now again I'm going to do for I in range 10.
You're shaping it by 4 by what?
Oh, sorry, 4 by. This is a usual this comma at the end. People just use it to make sure that they're doing just a one-dimensional thing. Okay. So let me just quickly do this. String I and then equals to components. This one also, there must be a better way, but I couldn't make the other ones work. So shift enter, what it does is it's PCA components. Oh, PCA dot components, sorry. Shift enter. No, what's the problem? Oh, range 4. We have 4 components. Okay, so that's good. And then if I look at the training, now it populates everything with the components. So what you have is now a new set of coordinates. And with this, you can, again, take any test data and then compute its 4 components and calculate the distance between them. Okay, now I'm going to write a new classifier using the PCA. And this time I'll be using, well, should be similar to previous ones, so let me go and copy. Here it is. So I'm going to copy it here. But now I'll be using the PCA as well, so global PCA. And then I first have to fetch the components of the item. So I'm going to do components equals to PCA.components underscore at numpy array of item.iloc 64 and then dot reshape 64 and 1, and then again get the result into single array, one-dimensional array. Yeah, this doesn't read well. Let's do this. Let's make this into bitmap. Part of the data would be this much, and I am reshaping it so that it becomes a column vector. If I do the bitmap vector and the PCA components matrix multiplication, then this will give me the 4 components, and then reshape 4 would give me a one-dimensional array. Okay, and then now the distance will be populated by taking the distance between chaining iloc. Well, instead of using the first 64, I'm using the last component, so it'll be -4 colon. And for some reason, I needed to make this into a one-dimensional thing again. So np.array then I'll reshape this as 4 comma. Okay, and then this one will be now components. Okay, and the remaining part will be the same. Okay, so that's good. So shift enter. Now let's see if classify 2 is as good as the original one. Note that we're using just 4 information rather than 64, so it's understandable if it makes more error, but it should be much faster because it's only using 4 information. Okay, so classify test dot iloc2 does give us 6, and did you notice that was faster? I think it was faster. The next number I believe was 2. Yep, it works. Okay, so now let's try to apply this to everything. So let's go up. We had to interrupt this one because it was taking too long, right? So I'm just going to copy this down here, and then I am going to use classify 2 instead of classify 1, and that should be good. All right, shift enter. Okay, so it took me like 3 minutes it's not as good because I've seen the one where I don't do the PCA. It's that one's actually almost perfect, except a few mistakes in the 8 and 9. But I do see that some of these are pretty good. Yeah, 6 is like near perfect. Okay,